So here we're working on Unit 5A. We're going to evaluate the nth root and use rational exponents. Here are our I can statements. One of the top ones is I can find the nth roots of a number. So that's a good way for you to evaluate what you understand. Things to remember, we're talking about perfect squares. And those are numbers where you can take a square root and get an integer, no decimals. So numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are very typical ones that you should be very familiar with. Just kind of run out of room with the other ones. We have put those on previous notes. Perfect cubes would be 1. That's 1 times 1 times 1. 2 times 2 times 2 would be 8. 3 times 3 times 3 is 27. 64, 125, 216, 343, 512, 729, and 1000. Those are your perfect cubes. Those are numbers that should mean a little bit of something to you. When you see that number sitting there, you should know that it's got a certain property with it. Okay. Now, the number like 64 should really catch your attention because it's a perfect cube and a perfect square. Okay, and it's also the 6th root. So 64 is a really cool number. All right, same thing would go with 512. All right. The index of a radical, the nth root of A is written as the nth root, like a square root would have a 2 there. A cube root would have a 3 there. The 4th root would have a 4 there. That's called the 4th root. That is the n value. That's called the index. That's a very important term, the index. When you're talking about roots, this nth root of A, n is going to be a number that is positive. So your index is always going to be a positive number. So in this case, if it's even, if it's an even value like a square root you would not typically write down a value. But you wouldn't write down an index number there. It's a 2, but we don't typically write it like we don't write a denominator that's a 1, or we don't write a exponent that's a 1. We don't write a 2 if the index is a 2. It's implied to be a 2 if it's not written. But if we're taking the square root of a value that's less than 0, okay, we get no real root, no real nth root. You might say that it would be plus or minus 2i, and that would be correct, but I is an imaginary number. It's not a real root. If it's 0, if you're taking the square root of a 0 value, you get a single answer. And if you're taking the square root of a positive number, okay, specifically on both sides of an equal sign, you would get plus or minus. You'd get 2 different values. Now, don't get that confused with walking down the street and you take the square root of 16, it's implied to be 4. Okay, 4 is the square root of 16, but when we're solving equations, that's where the plus or minus comes from. with the n value being an odd value, like the cubed root of a negative. Cubed root, what times what times what makes -8 3 times. That would be exactly -2, not plus or minus, just -2. The cubed root of 0, of course, is just 0. 0 times 0 times 0 is 0. And then if a value is greater than 0, like 27, there's only one way you get 27, working with cubes. 3 times 3 times 3 makes 27. Not plus or minus 3. -3 times -3 times -3 makes -27.
Mr. Weber.
So when we come down and look at rational exponents, those are exponents that are fractions. Okay, it gets a little weird. Okay, here we have a m to the n. You could also write that with the m to the n, more like the fraction that we're familiar with it. We can reorganize that a little bit. We often will. We'll put the m on the outside. By putting the m on the outside, then we can work with the radical that is formed. Okay, the denominator is your index. Your numerator just stays on the outside. Mathematically, you can put the m on the outside or you could put the m on the inside. It really doesn't matter. So what would go on in this blank would be the nth root of a to the m power. If it's a negative means that you're going to put it into the denominator. So you still have your same fraction of m over n. Then you pull that m out just like we did above. Then we're going to write this as a radical with the index being whatever the denominator is. So let's try it here. We have 125 to the -2/3. It might be easier if you stand your fraction up rather than having it sideways. So that's going to be the same thing as 1 over 25, or -125 to the 2/3. The negative puts it into the denominator, not the -125. That's no problem. That's just still -125. It's the negative exponent that puts it into the denominator. Then we have the 1/3 with the numerator on the outside. The 1/3 means that we are going to take the cubed root of 125 and square that. The denominator is your index. The denominator is the index. So the cubed root of 125 is -5. And we're squaring that, so we get 1 over 25. Woo! That was a little crazy. The negative exponent puts it into the denominator. Then we take the 3 and we write it as a cubed root of 125, and we square it with the numerator. So the cubed root of negative 125 is negative 5. Negative 5 times negative 5 times negative 5 is 125, or negative 125.
Mr. Weber,
Got it.
so for the first problem we did, like with the A and the M, what's in the blank like parenthesis spot? Yeah, the top one. Like what is that, like half of a heart? Like what is that?
All right. This is the n. This is the denominator. So this is an n value. That's an n value. The same exact thing that I have written here, that we write it as a fraction, and we put the n value as your index. And we have our radical with our numerator on the outside. Great question. You got to understand what you have. No problem. So whatever the n value is, the denominator is, that's going to be the location of the index. So it's always the bottom of the fraction. So when we did this problem, we had the 3 is the denominator all the way through the problem. What does the denominator mean? It means it's going to be a cubic value, because the denominator is a 3. We're taking the cubed root of 125. And then we're squaring. We're doing what the numerator was. It was a 2, so we square that. And that's how we get 25, 1 over 25. Great question. You'll have a chance to practice some of these. So notice that this is a negative. So we do 1 over 64 to the 1/6. Now this is a 1/6. So that means you're actually doing the 6th root of 64. Whatever the denominator is, that's going to be your index. And 2 times 2, that makes 4. Times 2, that makes 8. So 2 to the 3rd power is 8. 2 to the 4th power is 16. 2 to the 5th power is 32. 2 to the 6th power is 64. So the 6th power of 64 is 2, and that is in the denominator. So this is 1/2. Now, because this is an even root, all right, this is a 6. So that's how we know that this is going to be plus or minus. It's not a plus or minus 2, but it's a plus or minus in front of the fraction.
Can you explain how you got 2 again for the bottom? Because I'm confused.
Sure. I know that the 6th root of 64, what makes 64 6 different times? What number to the 6th power makes 64? That's what's being asked. So 2 times 2 times 2 times 2 times 2 times 2, 6 2's make 64. So the 6th root of 64 is 2. Just like the square root of 9, the square root of 9 is 3, because 3 times 3 is 9. The square root of 16, the square root is 4 times 4 makes 16. So the 6th root is asking for 6 of the same number to make 64. So in this case, there is no negative, so there is no fraction. We're just going to look at the 9 to the 1/2 power. because that's taking the numerator and putting it on the outside. That's asking us to do the square root. If you want to put a 2 there, you can. You don't need to, because that is the square root of 9 to the third power. That's going to be, sorry, that's going to be 3 cubed, which is 27. Now, let me go back here to this one. I put a plus or minus in here. I'm going to pull out that plus or minus. I'm sorry. We get plus or minuses when we're solving an equation. This is just evaluating. So we're not going to get a plus or minus here. It would just be a half. Like this is just 27. This is not going to be plus or minus 27. Okay. Just evaluating. So this is a negative again. So we're going to put it into the bottom of our fraction. Then we're going to be looking at the fourth root of 16, kind of to the first power. Don't need to write that. And 2 times 2 times 2 times 2, you see 2 there is a 6. So it takes 4 of them to get to the 16. The fourth root of 16, what is 4 times itself to get to 16? Well, that's 2. So 2 is now in the denominator. That's also a half. Well, there's no negative, so there's no fraction. So this is 36 to the half power. You should be learning that half power is the square root. If you need to write it physically as a square root, you are welcome to do that. You shouldn't need to put a 2 in the corner, but you could if you must. The square root is 6. Square root of 36 is 6, and that is still cubed. So that is 216. 6 times 6 times 6 is 216.
Mr. Weber?
All right, so now hopefully you've taken your chance to work through these. This is a negative. So we're going to do 1 over 8 to the 4/3, which we like to pull that 4 out just for organizational purposes. Now you might know what 8 to the 1/3 power is. But if you don't know 8 to the 1/3 power, you can rewrite this as the cubed root of 8. That's what the 1/3 means. That's what the denominator of 3 means. It's an index. It's an index of 3. That you should be aware is going to be 2. The cubed root of 8. 2 times 2 times 2, 3 different numbers. 3, that's what the index means. 3 different numbers makes that to the 4th power. So that's going to be 1 over 16. 2 times 2 times 2 times 2 is 16. Now this is kind of a silly one. This is 1 to the 1/8 to the 7th power. So that's the 8th root of 1. So what to the 8th power makes 1? 1 times 1 times 1 times 1 times 1 times 1 times 1 makes 1. And when you raise that to the 7th, you still get 1. Sydney, correct. And number 27 does not have negative exponents. So we don't have to have a fraction except for the exponent, of course. So this is the cubed root of 27 being squared. So this is 3 being squared, which is 9. Now what you don't want to do is get caught using a calculator. not caught, that's not the term I meant, but you don't want to be calculator dependent on these. These are to be used without a calculator. Hopefully you can do these without. We will go over how to use a calculator shortly or next, but that's how we work through those problems. Then by using our calculator, now this is the cubed root of 10. What times what times what makes 10? Well, 3 times 3 times 3 makes 27. 2 times 2 times 2 makes 8. Neither of those numbers make 10. You can use your calculator and you could do 10 raised to the 1/3. That's one way you could do it. Or you could use your math key, which is above the square key, the math key, and go down to cubed root. So you're doing the cubed root of 10. What times what times what makes 10. And there's a pretty good approximation of it. So this is going to be approximately 2.15. Now for this next one, it has a negative exponent. So it's going to be 1 over 21 to the 1/4. So you could do that, or you could do it to the 4th root of 21. Either way. So you know what a fractional exponent is now. So 1 divided by 21 to the 1/4 power. Whoa, that's not going to work. 1 over 21 to the 1/4 power, or 0.25 power, is going to give us a decimal. That's going to be the same thing as 1 divided by. We would first type the 4 for the 4th root. Then we'd go to our math button, which is above the square button a couple. We go down to number 5. Because we wrote a 4 and hit enter, that's going to put the 4 as the index. And we can put a 21 in there, and that gives us our same exact decimal. So they mean the same exact thing. So this is approximately 0.47. So this is the 6th root of 13. If you want to write that as 13 to the 1/6, you're welcome to do it. It means the same thing. You can type in your 6, go to math, go down to number 5. See the X? That's where the 6 is going to go. It's going to replace the X. And that's of 13. And we get 1.53. We're rounding to the nearest 100th. Last one, this has a negative exponent. So we're doing 1 over the 4th root of 80 squared. Now you could write that as 1 over the 4th root. Oh, well, here, I won't write it there. Silly me. You could, if you wanted to, use your knowledge now that 80, you could put this back into a fractional exponent 2 to the 4th, right? Isn't the index the denominator? And you're squaring it, so that goes into the numerator. You can reduce that. So this is really to the 1/2 power, and 1/2 is the square root of 80. So this is 1 over the square root of 80. So 1 divided by the square root of 80, that gives us a decimal, which would have been the same thing as 1 divided by the 4th root of 80, but our square would have been on the outside. Let me be sure I get all my little terms in here. And you see that my decimals are exactly the same. So we simplified it correctly. Either format would be accurate. We're just trying to get approximately 0.11. All right, now we're going to solve. So when we solve an equation, x to the n equals a, we're going to take the nth root, or we're going to raise both sides by 1 over a, or 1 over n. So in this case, if we divide both sides by 2, we get x to the 6th power equals 729. And when we take the 6th root of both sides, because that's what gets rid of the power of 6, we get plus or minus a number. So 3 times 3 times 3 times 3 times 3 times 3, that makes 729. Just want to get through a couple more of these. So here we're going to take the 4th root of x plus 8 to the 4th power equals 2. So when we take the 4th root of both sides, because of the 4 is the power, that leaves us with just x equals 8. All right, and this is the 4th root of 2, which would give us plus or minus a number. And when we subtract the 8 over, you could either turn that into a decimal, all right, or you would get that. They're asking us to round to the nearest. So the 4th root of 2 gives us a decimal. We're going to take 8 and add it to that 4th root. That gives us 9.19. We added it, so we got 9.19. Oh, actually it was -8, wasn't it? My bad. All right. So we've got -8 plus our answer. That's is actually -6.81, sorry. -6.81. And I'm going to go up there and get this into my memory. So I'm going to say -8 minus my answer. So you're -8 plus that and minus that. So -9.19. Whew. So now we're looking at the third part C here. We would add 9 over, like we're solving any equation. This is the cubed root of 40. Not the cubed root. This is x cubed equals 40. Some number times itself 3 times makes 40. Okay, 4 times 4 times 4 is 64. So we know the answer is going to be smaller than 6. So a way to get rid of the cube is to take a cube root. And we're going to do that to both sides. So that leaves us with just x. Now, when we do the cube, we do not have plus or minus. So in your math key, you can go down to number 4, and you can take the cubed root of 40 to get 3.42 as an approximation. Approximately 3.42. Now we come on over, we have a population P of a certain animal species after T months can be modeled by this equation. So P is the population, T is the months, where C is the initial population. So the initial population is 75. So 75 is our initial population. The population P of a certain animal is modeled by this, where C is the initial population. Find the population after 19 months. So in this case, we are going to figure out what 1.21 to the 19 thirds are. So 1.21 to the, nope, wrong key, to the 19 thirds. There it is. That gives us a number of 3.34. And we would times that by 75. We have about 250, 251. We'll call it 250.82. All right, and if you had troubles with animals being partial, that is somewhat close to 251. But if we're going to use calculators, we might as well show exact values like that. I'm not worried about a partial animal. Over here with the volume of a beach ball. All right, this is spherical, a big round circle beach ball. We know what that is. It has a volume where R is the radius of the beach ball. We're going to estimate the radius if we know the volume holds this many square inches. So the volume is 382. All right, so maybe if we were trying to figure out how big a beach ball would be if it had to hold this much, you could multiply by 3. So we're going to have 3 times 382. 3 times 382 gives us 1146. That leaves us with 4 pi r cubed. Then we can divide by 4 pi all at the same time if we like. We just need to be sure to do that correctly. 1146 divided, just be sure you divide by the 4 pi. You want to be sure both the 4 and the pi are dividing the 1146. That gives us 91.20. But I'm not worried about how you round that, because now we're going to take the cubed root of our 91 and some odd to give us R. So what we should do is do our math button. We go down to cubed root because we're taking the cubed root, but we want to type in answer, ANS. That is underneath the 3, that's actually the negative key that you would hit, not the minus key, but the negative key has the ANS. So you'd hit this. It's underneath the 3, but it's part of the negative ANS. So that takes the previous answer, and that gives us 4.5. So that's approximately 4.5 inches.